Hey guys, here is our lesson on the metric system. Make sure that you have a calculator handy. However, you're going to take notes on this. Make sure that you're ready to go. And it might be a Google Doc, it might be a piece of paper, it might be a page in a spiral notebook. Totally up to you. But you definitely are going to want to know all this stuff. So before we get started on the math part of the metric system, I just wanted to share a couple interesting facts, some of which you probably already know, some of which might be a surprise. The fact that you probably do already know the United States is the only developed nation on the whole entire planet to not use the metric system. Even though, and this might be the part that surprises you, we were officially authorized to start using the metric system back in 1866. Because that didn't go so well, Congress passed a law in 1975 trying to increase our use of the metric system. And then again in 1988, we designated the metric system as the preferred system of weights and measures. Clearly that didn't happen. And it's come at a pretty big cost. Back in 1999, a team at NASA was working on the Mars rovers, and one part of the team was using the metric system. The other part was not. They were still using the imperial standard system of weights and measures. Of course, when the team came back together and put all the pieces and parts in place, the rover blew up, costing us $125 million because we weren't metric. So metric is good. Metric is what we will be using in science this year. And I love the metric system, and I'm excited to share why. So let's say that we had a cube, and that cube had side lengths of 1 centimeter. So the volume of this cube is going to be length times width times height, 1 centimeter times 1 centimeter times 1 centimeter. We're going to have 1 centimeter cubed, 1 centimeter cubed, which is the same thing as 1 cc. So that's what cc actually stands for, cubic centimeter. So if you like to watch doctor shows on the television and you've ever heard a doctor or a nurse call for 12 cc's of epinephrine, they're actually talking about cubic centimeters, which is magically the same thing as a milliliter. So we can go from this unit of length, the centimeter, and relate it to this unit of volume, the milliliter. 1 cubic centimeter, totally the same thing as 1 milliliter. Now let's say that I take this 1 centimeter cube, my 1 milliliter cube, and I fill it up with pure water. Now this only works for pure water, but it still works, so it's magic. So it's not magic, it's actually reality, but it's pretty fabulous reality. So again, my cubic centimeter filled with pure water is going to have a mass of 1 gram. So 1 milliliter, 1 cubic centimeter, 1 gram of pure water. I know, it's amazing, but wait, there's more. Let's say that I take my gram of water in my 1 centimeter cube, my 1 milliliter of water, and I want to warm it up. It's going to take me 1 calorie of energy to get my 1 gram of water in my 1 centimeter cube to get warmer by 1 degree Celsius. It's amazing, right? I know you're amazed and astounded. It gives me chills every time I think about it. On to some of the basics, the boring stuff that I know that you already know, but it's worth repeating just in case. So our basic units of the metric system: grams for mass, liters for volume, meters for distance. We're going to talk a lot about moles in chemistry this year, but for now, get comfortable with grams, liters, meters. And then, of course, our really common prefixes: kilo, centa, and milli. Kilos times 1,000, centa is 1/100th of something, a milli is 1/1000th of something. So practicing those basics really quickly, if I have 1,000 grams, of course I'm going to have 1 kilogram. If I have 1/100th of a liter, that's going to be 1 centiliter. 1/1000th of a meter will be 1 millimeter. Be careful with these lowercase n's because milli is not the only prefix I want you to know. We're actually going to go big, and we're going to learn from tera, 10 to the 12th, all the way down to pico, 10 to the minus 12. So figure out a way to get these guys memorized. Tera, giga, mega, kilo, hectodeca. The base is just a meter, a liter, a gram, a second, a mole, whatever it is that we're talking about. And then getting smaller, chunking things down to littler pieces, decicent, millimicro, nanopico. Quick word about micro. This is 1/1 millionth of something. Since we're already using M for micro, we actually use the lowercase Greek letter mu, this U with a funky tail in front of it, for micro. So be really careful about that one. And then our other M, mega, is going to be capitalized. So big M for big mega, little m for little milla, lowercase mu, this weird U thing for micro. Again, make sure you get those memorized. So practicing some conversions that are not just ones and thousands. So if I have 45 meters and I want to convert it to centimeters, well, I know that 1 meter is equal to 100 centimeters. If I have 45 of them, then I must have 45 times 100, or 4,500 centimeters. Let's say that I have 6.7 grams, and I want to figure out how many kilograms that's equal to. Well, I know that 1 kilogram is 1,000 grams. I only have 6.7 grams, though, not a whole 1,000. So I can take that 6.7, divide it by 1,000, and that's going to give me my kilograms. So 0.0067. 6.7 divided by 1,000, 0.0067 kilograms. So sometimes we have some more challenging conversions that we need to do, and so we can apply some conversion factors. These are really just fractions that are equal to each other, top and bottom, numerator and denominator, kind of like 2 over 2 equal to 1, or x over x also equal to 1, or ml over ml also equal to 1, or 3 plus 4 over 7 also equal to 1. So know that our conversion factors don't necessarily have to look the same, top and bottom. They just need to be equal to each other, numerator and denominator. So this dimensional analysis process, just our fancy words for doing conversions, we're going to use these fractions, these conversion factors that are the same top and bottom. So this problem, how many liters in 3,456 milliliters? We're going to start with that given, 3,456 milliliters. I'm going to multiply it by some conversion factor that puts together liters and milliliters. Well, I know that 1 liter is equal to 1,000 milliliters. This guy isn't changing the value of anything because it's equal to 1. Since the top and the bottom, the numerator and the denominator, are equal to each other, this fraction is equal to 1. I'm not changing any values. I'm just changing how things look. What's magical is that my milliliter on the top over here, you can pretend like it's on top of a 1. My milliliter on the top here and my milliliter on the bottom over here totally cancel each other out because I'm multiplying. So what I have now is 3,456 times 1 liter divided by 1 times 1,000. When I do that math, 3,456 divided by 1,000, I get 3.456. And the only label that I have left in this whole big thing is the liter. And that answers my question, how many liters are in 3,456 milliliters? Well, there are 3.456 liters. Final answer. So next one's a little bit trickier. How many picometers in 12.4 megameters? Well, I'm still going to start with my given, that 12.4 megameters. And instead of writing a separate fraction, I'm going to squish my fractions together in what we adoringly refer to in the chemistry world is the railroad track, which you will come to love or hate depending on how close you hold chemistry to your heart. Anyhow, so all this space is right here is a space for a fraction. So it's just like this one right here. We're just going to smush them together to save space. So my 12.4 megameters, I need to get rid of megameter and get it to picometer. But I don't actually know how many picometers are in a megameter. I do, however, know that there are 10 to the 6th meters in every 1 megameter. So I got rid of megameters, top and bottom, but I'm not quite done yet because I only have meters. I need to get to picometers. I know that there are, in fact, 10 to the 12 picometers in every 1 meter. A little bit more magic. Meters on top and meters on bottom cancel out. So I can get rid of megameters, turn my megameters into meters. I can get rid of my meters, turn my meters into picometers. And my answer is going to be everything multiplied across the top divided by everything on the bottom. So 12.4 times 10 to the 6th power times 10 to the 12th power divided by 1 divided by 1. You can pretty much ignore that math. And you're going to get 1.24 times 10, 10 to the 19th picometers, which is a lot of picometers. All right, so here is a slightly more challenging conversion problem. We're going to have quite a few conversion factors, one of which is actually going to combine our metric system with an imperial standard system. So I was driving this morning at 58 miles per hour, and I want to figure out how fast that is in meters per second. So I need to get rid of my miles and turn it into meters. I need to get rid of my hours and turn it into seconds. We can go in any order. I'm just going to do miles first because it's first. So 58 miles, I need to convert miles to meters. I do not actually know how many meters are in a mile. I do know, however, that there's 1.6 kilometers in every 1 mile. You don't have to memorize that. If I ask you a question about kilometers and miles, I will tell you what that conversion factor is. So I've gotten rid of my miles. Miles cancels out. I have kilometers per hour. This is a good start, but not yet what we're looking for. I can get rid of my kilometers by putting kilometers on the bottom. Turn my kilometers into meters. I know that there are 1,000 meters in every 1 kilometer. So now my kilometers are going to cancel out. I have meters, which is good because that's what I'm looking for. But I'm not done because I still have hours. I don't want to know how many meters in an hour. I want to know how many meters in a second. So now I need to get rid of hours and turn those into seconds. So I have hours on the bottom. I can't put hours on the bottom and get hours on the bottom to cancel out. I'm instead going to have to put hours on the top. There are 60 minutes in every 1 hour. And then in every minute, there are 60 seconds. My hours cancel out. My minutes cancel out. And I'm left with seconds, which is good because that's what I'm looking for. So now all I have to do, it's quite a bit. I'm going to multiply by everything on the top. I'm going to divide by everything on the bottom. And when I do that, I get an answer of 26 meters per second. So now what I'm going to have you do is pause the video for just a little bit, do these practice problems, and then restart the video and check your answers. Here are answers. If you are unsure of why the right answer is the right answer, come and see me in tutorials and we can work on it together. Guess what? One more set of practice problems. Do these in your notebook, on a piece of scratch paper, wherever it is that you need to work. Come back and check your answers. And here are answers. Again, if you have any questions, come and see me in tutorials. And I hope that you have enjoyed immensely our first video lesson. I promise I'm going to practice talking to my computer screen so that this gets a little bit better. If you have any feedback for me, stuff that was helpful, stuff that was less helpful, let me know. These videos are meant for you, not for me. So I want to do them in a way that works for you guys. And that is the end. I will see you in class.